Here is a Kenmore branded dehumidifier, which may look fairly typical from the front, but it's anything that from the side. This is a very odd dehumidifier, very strange form factor. It's very similar in design, almost like a casement window air conditioner. This is the Kenmore 40-pint automatic dehumidifier, model number 75940, with the Blotter branding, which is the same branding that's on this little 15-pint that I have over here. Oh no, it's a 12-pint. 12-pint dehumidifier 5012, the Blotter. So I guess these are the same series, even though they look nothing like each other and are of totally different builds. This is a Coldspot product. Kenmore 106.759400, serial number E84831509. Maybe somebody can decode the manufacturer date based off the serial numbers. It contains, this is 40 pints. Oh, duh. It does say 40 pints. The capacity of the performance is 40 pints. It contains 18 ounces of R12 refrigerant, 115 volt, 60 hertz. Made in the United States of America. It's allowed to draw 7.4 amps. I'm not sure what standard this was measured by. I believe the old AHAM standard is 60% humidity at, I want to say, 86 degrees. And we're going to come back to that in a minute. Here's the plug. It's a very long cord. Let's see, this has got to be close to 10 feet. Very long for something like this, which is nice. I think that this is probably a 1970s product. We're going to take a look inside here in a minute. I'll take the cover off and we'll try to find out when this is made. There might be a date code somewhere in there. So this might tell us what it was tested at. So we have 40 pint capacity. Oh, here we go. This Kenmore dehumidifier removes 40 pints of water from the air every 24 hours under test rating conditions of 80 degrees Fahrenheit and 60% relative humidity. Automatic humidistat turns on and off based on the humidity. Shuts off when it's full. It's got the signal light to say the bucket is full. 15 pint moisture pan. Hose connection, full swivel casters. The controls are actually hidden behind the front here, which is kind of odd. It weighs 53 pounds, 700 watts. The cord, it says the cord is 6 feet, but that's cap. It's definitely longer than that. I don't see a date on this paper. That's the warranty information there. Yeah, no date there. So this has this is a really unusual design. There's the evaporator, which is absolutely caked in dust, so we'll have to clean this out. There's the indicator light, And there's the humidistat. Unfortunately, this does not have automatic defrost, which is somewhat of a fatality in my use. This is why the camera is always breaking, because the tripod just falls over for no reason. In the back, the compressor is in there. I'll take a look at that. I don't know what the heck that thing in the middle is. That's not where the water comes out. I guess that's got something to do with the auto shutoff. The water just drips out through the hole right there. So this is a weird design. This one is like horizontal, whereas they're typically vertical. And although I think this is a very fascinating piece of equipment, I'm really not too fond of the design. I think it's got multiple flaws to it. So for starters, being wide as opposed to tall, the footprint on the floor is huge compared to other models. The airflow goes in the front here and out the back. So you'd think you'd want to put this side facing the front of the room because it looks nicer and it would blow air into the room, but it's not. The air comes out the back. So you're not going to want to put it up close to a wall. In fact, you're probably going to want to put the back facing the room. And then you have this moisture tray here, which slides in from the back. And because it's so long, you would need to keep the machine at least, well, pretty much twice its length away from the wall to be able to get the moisture pan out. And then maybe I'm using this wrong or something's messed up, but the cord gets in the way of putting the pan in. So if you pull it real taut like this, it kind of slips through, but if it's just sitting there, it's just totally in the way of the moisture pan. And even when it's sitting here, it's like all bent out of shape because the pan. So I don't know, something doesn't seem right about that to me. So I don't know, maybe the cord's not coming out the right spot, or maybe there's a second cover that should be on the back. I don't know. There's something, I don't like the way that is. It's in pretty good condition overall. Unfortunately, the cover got kind of scraped up in the vehicle on the way home, but that was a necessity for different reasons. I made sure that the front guard stayed in good shape, because we can always repaint this and restore it to perfection. This you can't fix, but this is in good shape, just needs to be cleaned up. This is one of my favorite styles of grills for air conditioners and dehumidifiers. So, interesting items about dehumidifiers. I'll talk about this as I take the cover off. Dehumidifiers, for whatever reason, since the very early 2000s, have become pretty much the absolute worst, most unreliable, and probably most dangerous, aside from products with lithium batteries, household appliances available. Over the last 2 decades, there have been tens of millions of dehumidifiers recalled for various different safety issues, almost all resulting in fire hazards due to underbuilt components and poor designs. And all this stuff is being enclosed in a flammable plastic housing, whereas these are metal, which is the way it should be. So dehumidifiers, they consistently don't last. They're consistently a hazard. I mean, you're lucky if you get 2 or 3 years out of a dehumidifier nowadays. Across all the brands, they're all like that. So I will not use modern plastic dehumidifiers unattended in my household. Not at all. If I step out of the house, you get the mail, it gets shut off. I don't even like running them while I'm sleeping, because they're just so dangerous. And it's kind of weird because, you know, air conditioners are pretty much the same concept in a different form factor, and we don't have tens of millions of air conditioners catching on fire, right? And there's been some issues with refrigerators, which are also pretty much the same concept, but we don't have tens of millions of refrigerators getting recalled. So it's definitely something with the dehumidifiers in particular. It's kind of weird. But that's the way it is. So, unfortunately, the one thing where the newer dehumidifiers kind of take the edge over the old ones is the operating temperature. From my experience, the older dehumidifiers like this one typically are only good to about 71 or 70 degrees. Some don't even go that low, and then they'll start icing up. Whereas the newer dehumidifiers, again from my experience, they tend to be able to run properly down to about 62 degrees before they start icing up. And although that's a very small number of degrees, because it's right on the threshold of working versus not working, it makes a big difference. And especially in basements, also from my experience, most basements that I've encountered are typically between 60 and 70 degrees. And so that threshold can often be the difference between a unit working versus not working. In my basement here during the winter time, if it's really cold, we can get down into the 50s down here if I don't have the heat on. But then in the summertime it can be 85. So it varies. This I would only be able to use in the summer. Probably end up using it upstairs anyways instead. So that's one thing that's interesting about modern dehumidifiers. The other thing that's interesting about modern dehumidifiers is somewhat recently the rating standards were changed. They were changed from testing the units at very high temperatures like 80 degrees to testing the units at 65 degrees, which is much more like a realistic real-world use case. I think most basements that are underground and damp are typically cooler than 80 degrees. I can't remember if it was 80 or 86. I thought it was 86, and maybe it's 80. Either way, even 80 is very high, much higher than it should have been. So these new ratings were changed to reflect a more typical real world use case. So arguably it was an improvement in the rating. Unfortunately, all those things are inconsequential if the machines are so dangerous that they shouldn't be trusted to run. This is not coming off as easily as I had imagined. I don't think that's causing the problem, but we'll take it out anyways. So in conclusion to this comparison, I have a newer dehumidifier that I use over the winter time. Attended operation only when I'm home. And in the summer, when it's not as cold, we will switch to vintage dehumidifiers, which can run all the time, unattended, and I don't think twice about them. Because not only are the housings metal, so if something did happen it wouldn't matter, they're built properly. Components are used that are built to spec to handle the operation, and they really don't pose any fire hazard at all. I've actually never heard of a vintage dehumidifier catching on fire or posing any kind of electrical hazard. So here's what it looks like with the cover off. Looks like some kind of commercial refrigeration equipment. It's very interesting. Inside the case we do have a data sheet, and this shows us the operation at different temperatures, and you can see it only goes down to 70, so the expectation is this is not going to work below 70 degrees. And you can see even at 70 the performance goes down quite a bit. But it's interesting data to have. Not a lot of units come with that information. We've got a full schematic here. And we have a date code. of 11 of 1978. Unfortunately, the paper is starting to deteriorate because of the moisture inside the unit, but all things considered, for a 50-year-old piece of paper inside the machine, they don't look too bad. Inside the machine, I'm noticing several additional things about the design that I really don't like. So for starters, we have the suction line is not insulated. So this whole suction line here, it will become wet during operation. We can see that the water has been dripping down into the pan here, which is causing some surface rust. Nothing major. What's more major is that water will come down like this and be on here, and then eventually drip down right onto the compressor contacts, which is one of those things that you really don't want to play with it unless there's a problem. So we're not going to go ahead and try to clean it up or anything, as long as it's making a good connection. But that's kind of a dumb design, so I think I will add some insulation onto this, at least from here to here, just so that it's not dripping on the compressor anymore. Here we have a very old school starting apparatus, which is really cool. That's a physical magnetic switch, I believe, so maybe we can see that in operation perhaps. Here's the fan motor, which of course has the oil ports. It is the Universal Electric Company motor. It should be oiled every 6 months. And on the other side, I'll go ahead and turn this around. We have the rest of the starting apparatus, which is a General Electric, made in USA. And there's the full part number. The compressor is a Whirlpool product. I don't know if Whirlpool and Coldspot have some kind of a connection. Perhaps somebody can fill me in with that information. Another problem that we're going to have to correct is these wires are sitting here freely up against the coil loops, and you can actually see the wear mark where the wire has kind of worn down the surface. It's right in the center of the screen. It's worn down the metal, and you can actually feel it. If you take the wire and push it like this, you can feel it sit ever so slightly down there. Same thing with this loop. It's worn away part of that loop, and this is why it's very important to have the wire tied down. Alright, so just a tie wrap here so that it can't vibrate would have solved that. Now granted, this has been running for 46 years and it hasn't caused a problem yet, but it quite possibly could. Now I want to underscore the overall lack of the presence of rust. Here, this is the evaporator coil, 2 layers, and there's pretty much no rust to speak of. If you get a new dehumidifier and run it for 3 weeks, it'll be rusted through solid. And this is 40 something years old and it's not even rusted hardly at all. So whatever this was made out of is exceptionally good quality materials. I don't know if this is just oxidized or whatever from the moisture, but it looks like there's a coating on this whole thing here which is not on here, because this doesn't get wet. Even these bolts, I bet these bolts would come right off. Yep. Every time I look at a piece of equipment like this, I just have to ask, what the heck happened? What happened to products over the last 30 years? What happened? Why could we build this 50 years ago, but we can't build this anymore? I don't know if that's the original fan motor or not. It looks newer than everything else on here. This is definitely an easily replaced part. The amount of dust on the blade is not really consistent with the amount of dust on the coils. They are pretty dirty. So quite possibly the fan was replaced at some point. The fans, interestingly enough, were typically the only failure point on these older dehumidifiers because people wouldn't oil them. Because it's pulling hot, dry air, the bearings dried up quick and they would lock up. Ironically today, a lot of dehumidifiers made today come with ball bearings in the fans, and now it's the refrigeration component that fails before the fan. But at least this is easily repaired. Well, let's go ahead and start this thing up. I don't really have a good viewing angle of the switch. Probably from the other side is the best option. I'll try to get some video of that switch in operation if we can see the moving parts. I don't know if we can from the way it's designed. Thermostat's just kind of sitting down here. We'll go ahead and turn it on all the way. Here's what the thermostat looked like. It's made in Mexico, 7837, probably 37th week of 78 maybe. I don't know what the one is, but it's working. Put that down all the way. And let's see, I think this is the best shot of the switch that we're going to be able to get. If I can get this stupid tripod to hold up here. I did actually get a new tripod recently, so we'll switch over to that one very soon. Alright, we're going to test at 119 volts, so just a few volts over what it's intended to run with. And here we go. Six amps to begin. Now when I first found this I thought it was flat, which I guess is something I've learned over the last couple of weeks, is that sometimes the hissing sound takes a very long time to stop. To me that should have stopped already, but it'll go like that for several minutes before it starts pumping for some reason, which is really rare for a reciprocating compressor. You see we're building no head pressure yet at all. So I gotta let this sit for a while. I'm gonna give it a good 10 minutes or so, and then we'll come back and keep recording. It's still making that sound. Sounds like just sounds like air at this point. But it worked a couple days ago. It did the same thing, just like those air conditioners. It needed a good 5+ minutes before it started working properly. been several minutes and we're still barely building any head pressure, if at all. And you can actually hear it. Listen to the sound as the amperage changes. You can hear it pushing the gas as the amps go up and down. So it really takes a long time for this to get the gas moving through. We're just getting a little bit of cooling on the top now. Now it is only 69 degrees down here, so it might ice up. I've tested this at like 74 and it worked perfectly. So, as discussed in the previous conversation, it might just be too cold for this to run. Still ambient temperature at the bottom. Discharge is lukewarm at best. Now it's finally starting to build some pressure. I don't think there's anything wrong with it, but it's just kind of unusual for a reciprocating compressor to take this long. It's very much behaving like a rotary. Frost is moving down, so I think that it's just too cold in here right now for this to operate properly. But we'll give it some time. It might frost. It might defrost itself once the pressure gets high enough. This is R12. I don't work with a lot of R12 equipment, so I don't really have a good feel for how long it takes for an R12 system to charge up. I do know that R12 is very low pressure compared to 22, which is what I work with the most. So maybe it takes longer. It's also not getting the full airflow because there's an opening up here at the top. How can we correct that? I might just put something over the top of it to block that opening. There we go. That should direct more of the air through the coils. Yeah, it's getting a lot of air through the coil now. Oh, look at that, it's already defrosted. See, it just wasn't getting enough air for that. It's a little frosty on the loops, but at least it's cleared in the coil area. Upon further inspection, I am mistaken about this apparatus here. That is connected to that hose thingy that goes into the bucket. So that has to be the automatic shutoff switch. How it works, though, is still a mystery. I thought it was one of those mechanical switches that will turn the start relay on and off based on the magnetic field from the power draw, but that's not what it is. It's been about 15 minutes. It's finally starting to come up to pressure now. We're going to see that the frost is going to start melting. I also turned the heat on, so now it's 72 degrees, which is going to be right on the threshold of where it's going to work properly versus not work properly. But it looks like it's going to melt for the video. See, this is now wet as opposed to frozen, and that effect will move down the rung slowly. It has frosted all the way through. It's now going back to the compressor cold. We're up to 6.68 amps, 562 watts, with a power factor of 0.748. So there must be a shaded pole motor in here somewhere. Maybe everything is shaded pole, I don't know. That's kind of unfortunate because if this was a B series with a PSC fan motor, probably could cut the power draw in half. But I guess this is all the fan motor is definitely shaded pole. I don't see no capacitor. Condenser temperatures at the top is around 80. At the bottom we've got 106 is the highest I saw going in. 34 on the evaporator, 33, 34, 32, so the evaporator is too cold right now. And again, it's 32. If you raise the ambient temperature of 2 degrees, it's not going to frost. But if you go down 2 degrees, it's going to frost. So that we're right on the edge. The compressor is 129 degrees at the bottom. Like 134 is the hottest point, so that's reasonable. Almost the whole front's melted off now. Got a couple drops coming down. It's been running for about a half an hour now. 6.87 amps, 596 watts, with a power factor of 0.74. It's allowed to draw up to 7.5 amps, so we are within spec. It's a fairly inefficient machine, but I will take inefficient, powerful, reliable, and safe over efficient, dangerous, and unreliable any day for any product. So we've got a little bit of ice up at the top here. It's icing up going back. So this is probably like 33 degrees. So we're right on the threshold of what it can operate at. It's 72 degrees in here, so this probably would be perfectly fine at 73, 74. It's usable the way it is, right? It's not going to ice up on the coil itself, but technically it's a little bit colder than it wants to be for operation. It kind of thaws out right before it goes into the compressor, so we're not into the danger zone of it slugging liquid. It's pretty much, there's a little bit of frost on there still. I think it's probably fine the way it is to use at this temperature. So we've got now 36, 36, 36, 37, 34, 33. So the whole coil is still very cold. On the inside here we're getting 46 average. But this is only the surface of the front coil. The second layer is going to be colder. Pretty reasonable condenser temps. And they're going down as you go up like it's supposed to. Let's see if the compressor cooled off at all. It might have now that it charged up. Well, it feels a little bit cooler. No, it's about the same. 133. 138, those are reasonable temps. Fan motor is 135 oil, that's also reasonable. So everything is pretty reasonable on this. Power draw, temperatures. It's starting to pull some moisture now. So I'd say this is working properly. It's got a full charge still. It also doesn't have quite as much airflow as it should because this is not making a good seal. So I think I'm going to go ahead and turn it off. We'll put the cover back on. I'm going to crank the heat up a little more. And I'll let it run for a while and see what it can do. That's definitely not low. You wouldn't hear that much noise for that long if it was low. Still going, very pronounced. The plug is a little warm. Not to the point of concern, but I think I would replace it. That's the problem with molded plugs. They just, over time, they wear out. I don't really know why. I think we need to get a chemist in here to explain that. One more thing to note before I put the cover back on. See, we got all this water here. It will eventually go down into these channels and go over to the drain. But look at all the rust that's caused. See, it just dripped right there. And then over here, this is unnecessarily getting the condenser wet. So this should have been insulated. I'm not sure why they didn't do that. Inherently it doesn't matter because it's ran for 45 years like that and doesn't seem to care, but in terms of best practices, I think that really should have been insulated. Look at how much material is on here. This is just such a better quality stuff than you can get today. And the fact that it's still working decades later really proves it. It speaks for itself. This is the way these things should be built. Alright, so we know that the cord has to feed through the back hole here in the back on the bottom. Like that. This is a little tricky to get off. I think I pulled, yeah, I did pull the bucket out, although now it's dripping, so I'm going to try to do it with the bucket on. I think it'll go for it. And it's also worth noting how easily this comes apart for cleaning and servicing. Once a day, I like a stinking puzzle trying to get them apart. Oh, that's interesting. There's a second plug or something. This piece here is getting a little warm as well. So this is the other end of the power cord, I guess. So this should be replaced also. Again, not heating up to the point of a hazard, but it's warm and it shouldn't be. Now, what's nice about these units is if this was to catch on fire, it's inside a metal box. It's not going to hit the house, it's going to hit the metal box. It's much safer. So much safer. Just by using a different material. Alright, so that's that. We'll screw this back on with a mental note that this needs to be rewired before we really use it. This goes... I don't think that's original. I wonder if this has been tampered with at some point. This just kind of goes on here like this. It's super easy to take on and off. Super easy to replace if you ever needed to. At this point in time, these thermostats, or these humidistats, I kind of feel like they've degraded. They don't work that accurately anymore. Probably was never super accurate to begin with because the fan's not a constant run. So when it satisfies, as soon as the fan stops, all the residual moisture from the coil is going to cause it to call for dehumidification again. So it's just not a super accurate design. This one at least is a little bit further from the coil. The modern day ones actually stick it right on the coil, and it's like, seriously? What I might even do is just cut this out and just crimp the cord together, because I don't need this. If I was to run this, I would run it continuous anyways. I wouldn't be shutting it on and off. But you know what? If after 45 something years, 46 years, if all it needs is a new power cord, just as a best practice preventative maintenance item, I'd say it's doing pretty good. I don't think that we're going to see any dehumidifiers made today still running in even 20 years from now. Probably not even 10. That's how pathetic the build quality and the design is. Gotta oil the casters too. They're working, but not as well as they should be. Alright, we're up to 74 degrees in here now, so this should be able to operate properly now. All the screws line up nicely, and this is great. It's like it was built to last. Oh, it was. Alright. Well, my camera battery is just about out. I'll turn this back on. Get one more startup of the compressor. And then I'll leave it to run in the 70 something degrees, 74 degrees down here. I'll charge up the camera for a while and we'll come back and we should find that it's working well. I'll have to do another video to revisit the that water thing, because I still don't know how that works. It's got to be something air censored maybe. I don't know. I wonder if it even does still work. Who knows? Probably does. It's a fairly quiet unit. Decent airflow at the back too. It's already built the pressure back up. Now it's only 43%, so it's only going to pull so much, but I think it will still pull moisture at that level. These are very powerful. This has been running for several hours now. It's up to 75 degrees in the room, and it's brought it down to 40% humidity. And it is dry over here. You can feel it when you walk in compared to the other side of the lower level here. It is super dry down here. So as of now, it's pulling 6.89 amps, 600 watts with a power factor of 0.75. The plug is warm, but it's not like alarmingly warm. It should definitely be replaced, but it's definitely not as bad as some of the other ones I've seen. It's 100 degrees. Plus it's got the hot air blowing on it, so the ambient's 77, so it's about 25 degrees over ambient temperature, which is not the way that it should be. But it's definitely not alarming. Just standard molded plug decay. Compressor cooled down. It's only 114 now. I figured that would be the case because once the gas starts flowing good, that's how the cooling goes back to it. So as far as the performance goes, it's excellent. It's still even at 40%, pulling quite a bit of moisture. I'm very impressed with this. I wasn't expecting much because the coil's not that big or thick, but it's definitely doing its job, and it's doing it with excellence. This must really pour some moisture when it's actually humid out. It's been water collected in the bucket so far. So that's it. It's working. The frost melted off the return line. It took some time. Focus, but it took about 73 degrees for the frost to melt off the return. Now it's 75 and it's working with no problem. So it'll be an upstairs unit. It definitely does not like the cold, but that's fine because I needed a good one for upstairs. And this weird form factor will be fine for the upstairs because I have the floor space, as opposed to downstairs here where I do not have the floor space.